Today's lesson is on Chapter 7. Lesson 4, we've been working with fractions and how to add and subtract them. We've done fractions with like denominators, and now we're going to focus on unlike denominators. Okay? So when you're trying to add and subtract fractions with unlike denominators, you need to rewrite each fraction as an equivalent fraction. Okay? So keyword equivalent. And where does equivalent come from? Where does the word equivalent come from? Gotham?
Equal?
Yeah, so basically it means equal, okay? So equal fractions. So make them equal. So what are you trying to make equal? What is it that's not equal at this point, right now? Ashika?
Two fractions.
The two fractions, what part of the fraction is not equal? Gia? The denominator, correct, okay? And then the second key word that we need to know, the vocabulary word, is common denominator, okay? So we have here, and just like it says, a common denominator is you need to have the same, okay, number for the denominator. Okay? All right, so those two vocabulary words are words that you need to know that will help you understand this lesson a little bit more today. And if one denominator is a multiple of the other, then you should use the greater denominator as the common denominator. So what do they mean by that? For example, if you have 4 and 12, okay, as your denominators, is 4 a multiple of 12?
Yes.
Yes, it is. So in that case, you're going to use the larger number, okay? Why does it make sense to use the larger number? Kyra?
Because you can divide 12. Like, let's say it was 3 over 12. Let's say it was 4 over 12. You can divide 4 by 3. So, like, it would be easier to multiply the smaller number by 3 because dividing is
Right.
hard.
You can't make 4 into something smaller, right?
Mm-hmm.
But you can make it into something bigger, which is the multiple, which is 12. So you'd be multiplying by 3 to get to 12 and changing the 4 to the 12 instead of changing the 12 to something else, okay? So otherwise, you're going to multiply the denominators to find a common denominator. So if they are not multiples of one another, so say you had 3 and 8, are they multiples?
No.
They are not, right? So what you're going to do is you're going to take the 3 and the 8 and you're going to multiply it together to get you your common denominator, okay? So 24 has now become your common denominator, okay? Because they are not multiples of one another, you have to create a new denominator that is the same, okay? Okay. So when asked to name their favorite fruit, 1/5 of the students in Ethan's class chose apples. And 1/4 of the students chose bananas. What fraction of the students surveyed chose apples or bananas? Okay, so when you have that or in there, what does that tell me?
Both of them.
You need both of them. So if I need both apples and bananas, what operation am I doing?
Addition.
Addition, correct. So I want to add 1/5 plus 1/4. Okay, because they asked for apples or bananas, which tells us that we need to add them together. Okay, so 1/5 and 1/4. Are the denominators multiples of one another?
No.
Count by 5s.
Yeah.
5, 10, 15, 20. And anywhere, do I run into a 4? No. Okay, so they're not multiples of one another. So what we're going to do is we're going to take the two denominators, the 5 and the 4, and we're going to multiply them together to get 20. 20 is now our new denominator. Okay? So we're going to change 1/5 into 20ths, and we're going to change 1/4 into 20ths. But how do you do that? How do you do that? How do you do that, Nishant?
You can, whatever you do, like if for 1/5 to the numerator and the 20 is the denominator, whatever the denominator, like 5 times 4 equals 20.
Mm-hmm.
So you gotta do the same thing for the numerator.
Very good. So you said you want to take 5 times 4, okay, to make it 20, right? So whatever we do to the denominator, we do to the numerator. So times 4 would give us 4 20ths. So same thing with 1/4. If we want to change 1/4 into 20ths, what do we have to multiply by to get to 20? 5 times 5. Whatever I do to the bottom, I do to the top. So 1 times 5 is 5. So now I have two new fractions, 4 20ths plus 5 20ths. When I add fractions together and the denominator is the same, all I need to add are what?
The numerator.
Correct, the numerator. So 4 plus 5 equals
9.
and then the denominator stays the same, which is
9
20ths. Is it in simplest form?
Yes.
Am I done with the answer?
No.
It is a word problem. What do all word problems need? Milana? Thank you, label. So what was the question asking us for? It said, what fraction of the students surveyed chose apple or bananas? 9 20ths of the students chose apples or bananas. Okay. Okay, second example, we want to find, so this is not a word problem, we just want to find what 5/12 minus 1/6 is. Now, is 6 and 12 a multiple of each other?
Yes.
Yes. Count by 6s and you run into 12. So do I need to change 5/12 into anything?
No.
No, it stays the same. It's already in 12s. But my 1/6 does need to change into a 12th. The equivalent fraction has to be 12s. So 6 times what will give me 12? Everyone?
2.
2 times 2. Very good. Whatever I do to the bottom, I do to the top. So 1 times 2 is 2. 1/6, 2 12ths are equivalent fractions. They're the same fractions, just written in two different ways. Okay? Now, can I subtract?
Yes.
Yes. So what is 5/12 minus 2/12? Everyone?
3.
Very good. Is this in simplest form?
No.
No, it is not. So I need to change this into simplest form. So what am I going to divide by on each side? What factor do they have in common? The greatest common factor that I need to divide by. Vedant. Huh? What am I dividing by? Not 4. Rajiv?
3.
3. Yes. Very good. I wouldn't be able to do 4 because 3 divided by 4 doesn't go into it evenly. Yeah. I could do the 12, but the 3 wouldn't work. So 3 divided by 3 is 1, and 12 divided by 3 is 4. And my answer is 1/4.